Welcome back to another video. Good to see you again. Today we're going to continue on electricity and we're going to elaborate on Ohm's law. Ohm's law is very important, okay? It's a foundational concept that you need to master. But I'm going to take you through it. So I've introduced to you the foundation of Ohm's law, which is V being proportional to I. V can represent your electromotive force, the force that push the charge around the circuit. Current is the rate of flow of charge, or how fast the charge moves. The stronger your V, the stronger your I. The lower your V, the lower your I. You eat more breakfast, you have more energy, you can run faster. If you are famished, you move slower, you are weak. Okay? All right. Remember in mathematics where you have a proportional relationship like y is proportional to x. And then what is the next thing you can do? You can actually write it, change this to an equal sign by introducing a constant. K is a constant. So in this case, we're going to do the same. We're going to write V is equals to I, and the constant that we're introducing is called R. Okay, this constant is what we call resistance. Okay, resistance, since this concept is by ohms, is measured in ohms. Okay, or this sign. All right, ohms. Right? Okay, so what is resistance? So imagine if I have a 4-volt EMF, all right, powering a circuit, and then the current flow, let's assume it to be 4 ampere. Okay, so imagine a person eat 4-volt worth of battery running at a speed of 4 ampere. Okay, so what happens when I put an obstacle in the midst of the path? Will the person run faster or slower? You are right, you will run slower. This obstacle, all right, okay, is similar to a concept of maybe friction, but in electricity, we call this resistance. And this obstacle itself is a resistor, okay, all right? So a resistor in a circuit diagram is represented by this symbol, a rectangular box with no lines in between. So this is a resistor. Okay, so let me redraw this circuit diagram. So let's say if I have this and then connected to a resistor, okay, and if I have again a 4-volt, okay, battery that's going on, right, and the current flow now is 0.5 ampere. I want to find out what is the resistance of the resistor. Okay, so what do I use? I use V equals to IR. So V is equals to IR. Okay, V is how many? 4. All right, but the corresponding current is only 0.5. Okay, means that there must be a factor of resistance that's pushing the current back. So R is equals to 4 over 0.5, and you'll get 8. And what's the unit for resistance? It's in ohms. Ohms, okay? So this is how you apply the formula. Let's have 2 more examples. Now I just use a part of the wire. All right, okay, so let's say if I call this AB and the current is flowing through, and this is a 8 ohm resistor, okay? All right, so let's say if I have 1 ampere of current flowing through an 8 ohm resistor, what is the potential difference across AB? Okay, all right, so again I use Ohm's law, V equals to IR. So V, in a sense, here, I is 1, resistance is 8. So how much work need to be done to push it across the 8 ohm resistor? I will need 8 volts for the potential difference, okay? All right. Another example, so let's say now I have a 2 ohm resistor, okay? All right, I want to find what is my current if the PD, okay, let's say is 4 volts. All right, what is the current flow? Again, V equals to IR. So V in this case is 4. Current is what I want to know. Resistance is 2. Okay, all right. So I flip this over. I is equals to 4 over 2. You will get 2 amperes. Okay, all right. Got the concept? All right. Fairly easy to apply. This is the most important formula you have to remember in this topic. Okay, now One more concept, stay with me. All right, so I have over here electric fan. Okay, when I switch the fan on, all right, the fan begin to move. Can you hear it? Okay, all right. So the thing is this. This fan have different power levels. This is at 1, at 2, 3, all right. So you can see that the fan speed is increasing, all right. But let's check out what is powering this fan. Okay, if I open up, you see a battery inside. Okay, so this is what we call the what? EMF. So as I press the button, do you think the EMF becomes smaller? Did I change the battery? No, all right. So the EMF has been consistent, but the output, okay, of the current, all right, has been changing. Okay. So the question is, if this is constant, how do I constantly change my I? What can I do? I can change my R, okay? So what is inside this device, inside the fan? There is a resistor. And the resistor is not just fixed, the resistor is changeable. All right, okay? So this is called a variable resistor. So the symbol of a variable resistor is like this, rectangle with an arrow. So there's a variable means can change, resistor inside. This device is also called a rheostat. Okay, so what can you do? As you press the button, the resistance will change from one level to the next level. So for me to have a stronger current, what is happening to the resistance? The resistance is actually dropping. Drop some more, greater output, all right? Okay, so what have we learned today? Ohm's law, V equals to IR. R is resistance measured in ohms. This is symbol for resistor, symbol for variable resistor, and this is how you apply the formula. See you in the next video.